Okay, we are looking first here. We're looking at the standard form of a linear equation. Okay, that handout I just gave you today should be there. It should be right at the top of there. Okay, so verbally what it says is that the standard form of a linear equation is ax plus by equals c, where a is greater than or equal to 0, a and b are not both 0, and a, b, and c are integers with a greatest common factor of 1. Okay. Some examples that you're seeing there. Notice it's the first example. We have 3x plus 2y equals 5. And you should see that a is equal to 3, b is equal to 2, and c is equal to 5. So, just to make sure you're clear with this, do you guys and ladies all see that the a, the number that represents the letter a, okay, is always in front of the x term? That's why in that first example, a is 3. The number b is always in front of the y term. So in that first example, b is equal to 2. Okay. The number c is basically the constant. The number c is always the one number in this equation that doesn't have a variable with it. So in that first one, you see 3x plus 2y equals 5. The one number that doesn't have a variable is c. So it's 5. Okay? So now look at that second example. You have x equals negative 7, a equals 1, and b equals 0, and c equals negative 7. So in the formula, x equals negative 7, okay, what number doesn't have a variable? X equals negative 7. What number doesn't have a variable? We're in this, let's see. See right here? Go ahead, Dawn. No, right, see right here, this equation right there where the cursor is, x equals negative 7. In that equation, x equals negative 7. Okay, is there a number that doesn't have a variable? Yeah, what number is that? It's negative 7. That negative 7 is c. See that over here? It says c equals negative 7. So that's how we know that. All right? Now, remember we said that the number in front of x is always a? In this equation, x equals negative 7. What number is in front of the x? Any of you know? 3. No, yeah, okay. What is it? 1. It's 1. Those of you that said 3, you're looking at the top one here, because you're right for that equation. But if we look at this equation down here where it says x equals negative 7, it's not 3, but it's 1. If you just have an x or a y, remember the 1 is understood. We don't have to write it, but it's there. So a is equal to 1. Now, you notice there's no y here. You see that? If you have no y, or maybe you have no x in the equation, in that case, the number that goes with it is 0. So b is attached to y, and since there is no y, that means b has to be 0. Is that starting to make sense? It might take a couple more examples, but okay, now let's look at our next one. Okay, so here, determine whether or not 5x plus 3 equals xy plus 2 is a linear equation, then write the equation in standard form. So, in order to do this, the first thing you want to do is rewrite the equation so that all the variables are on the same side of the equation. So notice how they did this. First, they wrote the original equation. Okay, right there. Now, the first thing we do is take this xy. Okay, what can I do to get xy on the left side of the equation? It's right on the board in front of you if you don't want to tell me. Go ahead, Don, what is it? Yep, we're going to subtract xy from each side. So you see here is some minus xy, and then over here we put a minus xy. Ladies, on task, please. So we have xy subtracted on both sides. This xy and this xy will cancel. So you have 5x minus xy plus 3 equals 2. Okay, now we want to get this 3 away from the left and onto the right. To do that, what do we have to do? So your turn. Subtract 3 from both sides. Very good. So, 3 minus 3 is 0. Okay, and then we have 2 minus 3. That becomes negative 1. So what we're left with is 5x minus xy equals negative 1. Okay. All right, so tell me, is that a linear equation? Go ahead, Don.
No.
It's not. Do you know why it's not? Yeah, because there is an xy term there, okay? So because the term xy has two variables, we cannot write the equation in standard form, and it is not a linear equation. Nevaeh, what is so funny? Okay. So again, since the term xy has two variables, the equation cannot be written in the form ax plus by equals c. That's the standard form. And this is not a linear equation. Yes? It's usually there. I don't know if it's back, if it got moved or something. Okay. Let's move to the next one. Okay. This time we have 3 over 4x equals y plus 8. We need to know, is this a linear equation and is it in standard form? Okay. So what do we have to do? Go ahead, Dom. What do we have to do? Okay, so again, we're going to rewrite the equation so that the variables are on the same side. The first step in doing that is what Dawn said. She wants to subtract y from both sides. So as you see on your screen, that becomes 3 over 4x minus y equals y plus 8 minus y. The two y's will cancel out, and you see 3 over 4x minus y equals 8. Okay? Now, are we done with this one? What do you think, Don? No, why not? What was your clue that we're not done with this? Okay, well, we don't usually see a lot of negative signs here, do we? And so, all right, so now, Dawn, pick somebody to tell us what we're going to do next. Yeah, pick somebody. Who'd you pick? Okay, what do you think, Zoe? We're going to write it in standard form. Okay? Now, if you remember, standard form is a times x plus b times y equals c. At the very top of the page that you have there, it tells you that a, b, and c have to be integers. What do you guys remember about integers? You got to think back a little bit. Dawn, what do you think? I speak up and I didn't hear. Okay, we can compare integers, but what do we know about integers? What makes something an integer? We did this in like very early January, if you remember back to it. Do you remember when we classified numbers, we had all those different types of numbers? It might have even been before you came. Yeah, you do remember those? Remember we had real numbers, we had integers, rationals. Right, right. So what do you remember about that time? Well, right, whole numbers are the counting. Right, you got they're not just the counting numbers. You got the wholes. The whole numbers don't have any decimals. They're just things like 0, 1, 2, 3. Do you remember what natural numbers are? Weren't they the counting numbers? 0, 1, 2, 3. Right? The next step up, those are your integers. So do you remember what integers were? Okay. So what do you think the difference between integers and natural numbers was? I got it back. What do you think the difference between integers and natural numbers would be? Not fractions. Okay, remember we said that one of you had told me that natural numbers had negatives. We said they didn't.
Does integers have negative?
Integers include negative numbers.
Oh, yeah.
So integers are negative numbers like -4, -3, -2, -1. Notice they don't have any of those. They don't have at this point the decimals or fractions. They're just the straight numbers, and they include the negative numbers. Okay? The other thing about integers is that they don't include the fractions or decimals. Do you remember the group that includes the fractions or decimals? Anybody remember what group that is? Started with an R? Yes, go ahead. Rational numbers. Very good. The irrational numbers included those numbers that had repeating decimals or decimals that truncated, meaning they ended, like 0.5. Those would be your rational numbers. The irrational numbers were things that you needed like the square roots for. Okay? So, when we go back to what we're doing now, the standard form, it says that a must be greater than 0. B and A are not both 0. And A, B, and C are integers with the greatest common factor of 1. if you look at the equation at the top, you have 3 over 4x minus y equals 8. Are all of the numbers there integers? You sure? Which one is not an integer? The 3 over 4, the 3/4. That's right. What can you do to make something an integer when it's a fraction? Yes, Dom? A decimal won't make it an integer. No. What's that? Yes. If you multiply the fraction by the denominator, that will make it an integer. Okay? Now, since you multiplied one item by 4, you then have to multiply every single item in your equation by 4. Okay? So you see up there the second step in red there, they multiply 4 times 3x minus 3 over 4x. And you see that minus y? Now it's minus 4y because you have to multiply the y term by 4 as well. Okay, then we go on the other side of the equation. Remember that whatever you do to one side of the equation, you have to do to the other side. So since we multiplied the left by 4, we have to multiply the right by 4. So what's 8 times 4? You need a pencil? Yeah. Does anybody have a pencil that he can borrow? Okay. I didn't bring any extra pencils with me, much less any extra mechanical ones there. So, you'll have to find something else to write with, Logan, if you can. Okay. Okay. Well, what is 8 times 4? Looks like you got one. 32, very good. So you notice you have, guys, ladies, no more throwing the notes or papers back and forth. Okay, so now look here. You have 3x minus 4y equals 32. That equation is now in standard form. Okay? What's a in this equation? Go ahead, Zoe. 3. Pick somebody to tell me what b is. Not just 4. Yeah, you have to include that negative. Very good. Pick somebody different to tell me what c is. Or what is it there? Sierra, what is it? 32. It is 32. So, Abby, you seen what's going on with that? Yeah. We try to get it in this form, right? Right here. The number in front of x is always a. So 3x, so a is 3. The number in front of y is always b, and in this case, it's the number in sign, -4. So b is -4. The number that doesn't have the variable called the constant, that one is always c. So here you have 32 has no variable, so c is 32. Okay? Since we're able to write that in standard form, we do have a linear equation. Any questions about what we're doing so far? Okay? Okay, the easiest thing I would tell you, if you have a decimal, the best way is to write the decimal as a fraction if you can do that. And then, since you have a fraction, we can do what we did there and multiply by the denominator. So if the decimal is, say, 0.6, you can write that as 6 over 10, then multiply by 10 throughout the equation, and that would give you what you've seen, like what you're seeing on the board. Yeah, you can do it with any fraction. If you multiply by the denominator, that will get you a whole number for that fraction. And it should get you an integer as well in case you have a negative. So okay, well, it looks like they've already got the answer given to you here. But how could we determine whether or not y equals 4x minus 5 is a linear equation? Okay. So the bottom of your page says, number 3. I know it is. So when she wrote up the practice here, she did not write it as a multiple choice. Came from the PowerPoint as multiple choice, but on your paper it's not multiple choice. So your problem says determine whether or not this is a linear equation. If it is linear, write the equation in standard form. So first of all, is this a linear equation? Okay. All right. It is a linear equation. Good. How do you know that? Dawn, you want to try it? Well, I think we're going to need more than just saying we have nothing else to do here. So yesterday we talked about equations in slope-intercept form, right? Is y equals 4x minus 5 in slope-intercept form? Still written up on the board in front of you there, to the right of our screen here. Okay? Slope-intercept form is y equals mx plus b. Okay? Do we have something here that's similar? What would m be in this case? Go ahead, Zoe. It's 4. What would you have for b? Go ahead, Zoe. It's negative 5. Okay? So, if you were to go plus negative 5, you could write that as just minus 5. That's what they did. So, we have something that is definitely in slope-intercept form. If it's definitely in slope-intercept form, that's going to be a linear equation. The other way you could prove that is to try to graph it and see if you get a line. Remember, one of the things we talked about yesterday is that if you have things like x squared, x to the third, if you have exponents that are not 1, those typically are not linear. But this is an exponent of 1 on your x, right? Those usually exponents of 1 are going to be linear. There's a couple exceptions for like when we divide by x. But most of the time, if your x is an exponent of 1, you're going to have a linear equation. So your next part says, if it is linear, write the equation in standard form. Okay, so what 2 things do I have to do to make this standard form? Okay, Zoe, you were first. What do you want to do first? Yeah, why not subtract 4x from either side? So here's the trick with that. If you subtract 4x from both sides, you're going to get y minus 4x equals negative 5. Is there a problem with that for anybody? Here's a hint. Go back to the very top of your page. And what does it say about a at the very top of your page? In that box where it says words, what does it say about a in there?
Less than 0.
Not less than 0.
And it's not 0.
What does it say? You're close. So what's it say? Greater than 0. What number is a? Is it the one in front of x or the one in front of y? It's not the one in front of y. It's in front of x. If you do a subtraction of 4x from both sides, what number will be in front of x on the left? Your equation will read y minus 4x equals negative 5. What number would be in front of x? What is it? Not just 4. Not 4x. You need the sign. Y minus 4x equals negative 5. That sign would be negative 4, right? Can A be negative? No, not according to our rules. So in this case, we would actually have to do something else. Instead of subtracting 4x, what's your other option? Because in standard form, x always has to be positive there. The number that's associated with x has to be positive because a has to be positive. What else could you do? If subtracting 4x wouldn't work and we want the variables on the same side, what option is left? Go ahead, Dawn. Well, before you would add 5, what would you do? You're not wrong, but we're not talking about 5. We're talking about the variables now. Subtracting 4x did not work. So what other options did you have? What's that? Not multiplying. Zoe? Not dividing. Okay. So don't get stuck with the idea of everything having to be on the left side of the equation. Okay, so if I was to do this, and I had, let's do it right here real quick. I'll get back there. So we have y equals 4x minus 5. You guys try immediately to subtract 4x from both sides. I understand that. But it doesn't work because you get this, where you have y minus 4x equals negative 5. This is your a. This is b over here. But a can't be negative. So that does not work. Okay? So if subtracting 4x doesn't work and we want all of our variables on the same side, the only other option is to work with y. We do this. So y minus y is 0. And now we get 4x minus y minus 5. Okay? Now what do you do, Dawn? No? You were telling me this before. Yes, now you add 5. So we have 5 to both sides, and you get this. You get 5 equals 4x minus y. What's a here? 4. So this is a. What is your b? No, b is, include the negative. So this right here is b. Technically there's a 1 there, so that would be b. And what's 5? It's c. So this is your c. That's how you put that into standard form. Now you see why the answer is c there. Okay? So don't get stuck assuming that you have to put all the variables on the left because that's what you're used to doing. Okay? You might have to put them on the right, even if that makes you a little uncomfortable. But that x term has to be positive in order for standard form to work. Okay? So we're almost done here. We've got about 2 minutes. So I think we're going to stop here. And at this point, your homework assignment